Hello, everyone. Welcome to this month's meeting, Rochester Xamarin. We have an exciting talk lined up for everyone today. It is April 28th, 2020. Before we get started, we always thank our sponsors. The .NET Foundation provides our meetup.com account so you guys can find the session, and my employer, File on Q, donates the GoToMeeting so we can make this virtual and make it available for everyone to attend across the world. We got quite a wide spread of the world here today. So without further ado, we have Clifford Aegis here today. He is going to be talking on a really interesting project. I know I always say I'm excited for our presenters every time, but I'm really, really excited for this one. He's doing a 3D printed Bionic Hand IoT device with the Xamarin app. And he was showing me stuff before the presentation. It looks really, really cool. I'm excited for it. By day, Clifford is an airline pilot, and correct me if I'm wrong, but the Xamarin and the coding is your hobby stuff, right?
It depends who you ask. Yeah, it is my hobby. I am a freelance .NET developer, but my wife seems to think that my flying is my hobby and my software is my work. But yeah, there you go.
All right, well, thanks for coming out. I'm going to make you presenter and let you continue to introduce yourself, and you can take it away.
Okay, thank you. Let's get it the right way now. I need to bring up my slides, which is that one. And maybe you guys over there. I should have done this earlier.
All right.
You should see my slides pop up shortly.
Yep.
There you go.
Yep.
There you go. Excellent. Right. So, yeah, my name's Clifford Aegis. I fly 787 Dreamliners around the world, or did until this little virus come along and stopped everyone flying. But when I'm not doing that, I'm a freelance .NET developer based out of London in the UK. And yeah, I'm going to talk about a bit of 3D printing, some IoT, and a Xamarin app. Ooh. So as I say, I fly, that's a 787 flight deck. I get to fly around the world. My passions are coding, electronics, IoT. I love learning new things and supporting others in doing that as well. But I get to fly a plane as well. So I've got sort of, two really cool jobs. I enjoy cycling, road or mountain biking, family, 3 boys, 2 dogs, a wife. So yeah, busy person. I mentioned the flying not just because I want to show off about, look at me, I'm an airline pilot. It's important to this project about being able to visit different parts of the world, which I'll come back to later on. So, but I want you to meet Caden. Now, Caden's now 15 years old. He's the son of 2 close family friends, Sharon and Paul, and he's a happy, bubbly teenager. They do exist. As you can see there, he's on a scout camp, happily just, always front of the line in doing something new, jumping in the water, always helpful. But as you can see, Caden's missing his left arm from just below his elbow, all the way through to obviously his hand. His other hand is, as you can see in the center photo, is missing the middle fingers. So he's kind of got like a claw, as opposed to a hand that you or I would have that could pick things up. These are all birth defects, so they're there from birth, and the human body is absolutely amazing in the fact that it can adapt. You take a sense away, maybe someone was blind, they'd adapt, and their sense of hearing and smell might pick up. For example, Caden's adapted really well, become very dexterous in the fingers he does have, or the finger and thumb he has left on his right hand. And as you'll see in the image there, he's got a claw kind of implement and an arm that's fitted that he uses, and he's become very dexterous at using that arm and that claw to pick things up, to the point where he's hopefully going to become a chef. So he's that adept at using that as he's going through life. He's had a prosthetic arm fitted by the hospital since pretty much birth, really. He's on to his 16th, I think is, yeah, because he's one more than the number of years he is old. So he's and then obviously the 17th is the one I've given him. As you can see there, the NHS and National Health Service here in the UK is obviously busy at the moment in the current climate, but you know, it's helped Caden by giving him a prosthetic arm. You can see there when I asked Sharon, his mum, for some pictures of Caden using his arm and a picture of showing how he controls it. You can see he's on the London Underground in the arm. He's attached to the it's his party piece really. Attached it to the handrail and stepped away from it so that it pulls out the socket. You can see the thin cable that goes up to a pad on his shoulder, and as he moves his arm backwards or his shoulder backwards and forwards, it opens and closes the claw. I'm not sure if you can see my mouse pointer there. There's elastic bands that fit across the claw, so as he relaxes his shoulder, elastic bands pull tight and grip onto things like the blue pole there. So they're best friends with the postman because the postman gives them lots of elastic bands from the mail they drop off every day. He leaves them a little bundle of elastic bands because obviously they break and wear out. So every 2 or 3 days, he's putting new elastic bands on. You can see here down in the left corner, the 2 arms. These are the arms that Caden's had made at Roehampton Hospital. So what they do is they take a mold of Caden's stump from his elbow, and then they use that mold to create an inset and then produce it out of fiberglass and put a socket on the end for the hook. So this hook that Caden's got here, he's had for many years and really doesn't really get to change it. He got a new one about 2 years ago, 2 or 3 years ago. Now, bear in mind, he's on this image, he's going to London 2012 Olympics. So that was back in 2012. He got a new hook a few years ago, and that's purely because the old one had broken, not because it had worn out, because it's metal. It's quite heavy. So he got a new one, and that just clicks into the end, into a mechanism in the end that allows him to click it in. So this arm, you know, he gets a new one every year, just like the kind of mother's towel is, you know, it's a bit too big when he initially gets it, but he grows into it, then he grows out, it's a bit uncomfortable and tight, so he goes back to the hospital, they make him a new one and he gets a new one. Now the NHS don't really give out full prosthetics to children. They'd only do it to an adult, and the reason for that is because obviously they grow and they outgrow them every year. Having said that, even to an adult, it's not something they do unless there's an actual need. So they might give out a motorized prosthetic to someone who is going to the Olympics, for example, because they're, you know, in the Paralympic team for Team GB. That is an example. Maybe they need it for their job, but otherwise, as an adult, all Caden's kind of looking to get from the NHS is something similar to this. Obviously, it won't be a skin tone plastic; it'll be fiberglass. But the hook and everything else is kind of what he's going to get from the NHS. Now that's brilliant. You know, the fact he's got that and he can use it, and the NHS are kind of giving these out. But these arms are around £5,000 each. Not sure what that'd be in dollars at the moment with the current exchange rate, but they're not cheap. You know, they take a week or 2 to make, from being molded all the way through to being produced and sent to Caden. And that is just for the arm part without the socket, the metal socket part in the end. So you can see they're not cheap either. And for a National Health Service, where in the UK it's free at point of use, there's no insurance system or anything else that covers the cost. So it's quite important that these things are cheap and reusable. And if he is to break it, it's going to be a couple of weeks before he gets a new one. So it needs to be, you know, good for point of use. Let's see, that's not giving me what I wanted. There we go. So back in, you can see it there, December 2016. There was a news story on BBC News and Sky News here in the UK of a dad that printed a 3D prosthetic hand for his daughter, and it was all over the news. The fact that he fired up his 3D printer and with a few pounds worth of filaments managed to print his daughter a hand for her to use. And obviously you can see the person in the picture there is one of the team that helped design the hands, and he's wearing one himself. so this was like, all over the news, and our children go to school with Caden and his sisters, and that's how we know the family for our children. So at the school gate that morning, dropping the kids off and walking out, and Sharon was saying, "Have you seen the news this morning about this 3D printed hand?" I was like, "Well, I did catch it while the kids were screaming and shouting and getting their bags ready for school." And she went, "Yeah, Cliff, you've got a 3D printer yourself, haven't you?" I said, I do, yeah, Sharon, I do have a 3D printer. She was like, "Well, do you think you could help?" I was like, "Well, let me look, let me see what I can do." So yeah, I kind of went along and thought to myself, well, hold my beer, let's see what we can get up to, let's see what we can come up with and do. So if I go across to my browser, which I hope you can see now, I started Googling, as you do. It's the first thing you're going to do with any new project. And I came across, I thought I'd start with the NHS and see what they had. And their links on the NHS website, which is a government website, goes to Limbless Association. Now, this page, and one day someone's going to update this page and it's going to completely blow my talk. But this page looked like this when I originally looked back in 2016. It still says useful links. This page is under development. Now, whoever the developer is, they're either dragging this out and this is going to be an awesome website at some point in the near future, or it's just been left and it's been left for dead and it's going to live like this forevermore. So that kind of website isn't much use. I eventually found the Team Unlimited, which is the one that the dad had 3D printed. Obviously, this site is live as you're viewing as well. I'm noticing not secure, so I'll let them know about that. It's moved on to the Isabella edition now. They had many editions before that. But you can see here, they're all 3D printed hands and bendable parts that you heat in hot water and bend them around. So that's black element there. And this yellow element here are these parts at the back here. So what you do with 3D filament, you put it in some boiling hot water, just like you would do with a gum shield you wear when you're playing sports, maybe rugby or American football. Heat it in some boiling hot water, wait for it to cool down just enough that you can bear the temperature, and you put it in your mouth. Here, you do it just enough to the child can bear the temperature. You bend it around their arm, or maybe a lump of wood that you've kind of made to the right shape of their arm. And then it forms the socket that you then put onto the child. So this is where I started, then started 3D printing parts. Now, can I just check, you can see my video camera, can't you? You can see me. I can't see or hear anyone.
Yeah, we could see your video camera. If,
yeah, okay. Yeah, it's right, because I'm going to hold some parts up. So it's obviously a bit difficult when you're doing it. I can't see you guys seeing me, if that makes sense. So this was an early version, this green hand here. So this is 3D printed from their design. You can see the metal spigot at the back is just glued, just hot glue gunned onto the back of the hands. Now, Caden's arm, I have one of his old ones here, one of the red ones that he had. He's outgrew this a little while ago. You can see here is the strap that goes across the back of his shoulder onto his other shoulder, and as he moves it backwards and forwards, you can see it opens and closes the grip, the claw at the end. So what we did was we replaced this and took this out. This one's not going to fit, actually, thinking about it, because it's the wrong size arm. And this here just sits in the end, so you'd have it like this. This wire went inside through a hole at the back, and as you open and close that, you'd do the same here, and it'd close the fingers around. So I thought to myself, yeah, I 3D printed this. Caden's going to love it. And off I went, trotting around to his house, and gave it to him. He tried it on, and about 30 seconds later decided he hated it. And the reason being is, as I'm sure you spotted, is these fingers close and that comes across, but there's nothing actually grips. I'm not sure you can see it in the picture, but it closes up, but it doesn't actually grip. So it was, he said it was useless. He could do better with his hook. We tried a few other iterations in designs, but it didn't really work for him. So back to the drawing boards. It's like, well, let's try something new. I then stumbled across the Open Hand project. I was Googling away and found this, and the dexterous hand. And the bit that drew me to this was because it's biomechanical, it's robotics. Now, I worked in the car industry for 11 years before taking up flying, and I worked mostly with with machine tools and robotics. So that's kind of where my engineering background comes from. So seeing Robotic Hand, I was like, oh, that's cool. It's now starting to get my interest, and I was like, well, I kind of, that this would be fun to play with. Joel Gibbard, as you can see the name at the bottom here, was the guy that developed this, and his idea was to come up with a 3D printed cheap robotic hand that can be used around the world and costs considerably less than $100,000 to produce and use around the world. So I followed this project. I started looking at Dexterous and looking through and coming up with designs. It was all in the name Open Hand Project. It was all on GitHub. So I followed that project for a few months while trying to work out what best to do. But then I noticed the fact that Joel Gibbard was also linked with a new company called Open Bionic. Now, Open Bionic, this is their kind of website now, and they are a company now. So when they first started out and I first started following them, again, the name Open Bionic, it was all open source on GitHub, and they were kind of pushing the design. People from around the world were helping out and doing PRs or emailing in ideas of ways they can change things. You can see now, they're a big company here in the UK. They're selling into the US and in France and Germany as well, in Europe. And they make an amazing product called the Hero Arm, as you can see there, being used by the children and even some adults as well. It's a fantastic product. It's not cheap. Obviously, as a company, you have the company kind of costs of owning and running a company. You have the cost of obviously the R&D, the staff that work for the company, etc. So these are not cheap devices. You're probably looking towards 10 to 15,000 for a device, and then there's obviously the ongoing kind of maintenance of that device as well. Now, the way they, you can see in some of the images here, there's a button on the back of the hand. So on the back of the hand here, there's a glowing button. You can see the glowing circle there, and you push that button to change the next grip in the grip sequence. And it glows different colors, so you can see at a glance which grip it is you're using and which is next one in the sequence. So, it's nice, but you've got to only use the grips that are in the grip sequence. So what kind of the hand can do, and their hands at the time had 5 grips. So it's good, and I liked it. So I downloaded the design. So I went to GitHub, and it's still there. Open Bionic, the Brunel hand was the design we used. You can see here, it's not been touched for 3 years for the STL files. So 2-3 years ago, well, you can see the last commit there, 2018, was the last time this project was touched. It was okay, it was good, but because they've now become a company and because they're now trying to get this product CE marked and approved around the world for selling and being used by the health services around the world, they needed obviously to go from an open source, or they felt they needed to go from an open source model to a closed source model, which is fine. That's what they chose to do. It's their product, it's their design, it's their intellectual property. But they left the designs up on the internet and GitHub because it was done under an MIT license. So it's like, fine, let's take the files and adapt them. That's what I've done and work through the project as we go. So if I go back to my slides. So this is Caden using his hook. You can see, like I say, he's quite dexterous. And you can see he's able to grab cups and make me a cup of tea. Which is always a good reason to go around there. So you can see he can pull out a tea bag, split them up. You can see how he uses his fingers on his other hand to get the tea bags and make a cup of tea. So you can see he's got a lot of dexterity. Now you speak with his parents, and you can speak with his prosthetic surgeon. Caden's a bit unique, in the fact that his parents have always made him wear an arm since birth. So even from about 6 months old, he's had a dumb arm, and as he's gotten older, it was introduced to a hook, and he's been a bit of a test case. Now other children tend not to use an arm, because they don't like it. They don't like the weights, don't like, you know, the fact that it can't do what a normal hand can do. They don't like the way they're stared at because, you know, what it looks like. So they tend not to wear it and accept the fact they've got no arm, which means that when you give them a product like what Caden's using, or what I've designed and built, or what Open Bionics have designed and built, initially it's a bit kind of challenging for them to use and get used to, and they think it's fantastic to start with, whereas Caden's been very critical of the product or the project in places, and that's been really good and pushed the project along, because he's come back just like you'd expect from any client that's asked you to develop an application for them. They come back, I don't like the shade of this, that's 2 pixels out to the right, I need it moved over. You know, whatever it is they're being critical about. Caden's been critical about this project from the get-go, and it's been amazing the fact that, you know, the relationship we've got, you know, the families, is the fact that he can say to me, Cliff, I don't like it, you know, I'm not going to use that. Right, okay, what is it do you not like about it? And he can be, you know, quite cutting in his remarks about it, but that meant that I'd go away, tail between my legs, and then come back the next day with something different. So as I say, I fired up the printer, and these were the first parts that come out of my old Mendel printer that I had at the time, Rep Mendel. And you can see the quality is, you know, pretty shockingly poor. You know, my printer used to get used to make boxes for my IOT projects, so, you know, it's quite good at drawing a box, and that was about all it could do. It wasn't cut out for this. So what do? Obviously, you go and upgrade your kit, and you buy a new printer. So I had a good excuse now. I was making an arm for someone, so obviously I needed the latest and greatest. So I got myself a Prusa Mark III i3 printer, which is just behind me, and you can actually see a second one being built at the moment. And I started building it. Now I put a circle around the blue part there. All the black kind of corner parts and segments of this printer are all 3D printed. When I built this printer, that section there, I broke. I snapped it in two when I was building the printer. So I called up Prusa and chatted to them on the online chat bot, and they sent me the 3D file and said, do you have a 3D printer? If not, we can send you a part, but it'll be 2 weeks. So I fired up my old Mendel printer, and it's still got it to this day. Actually, that blue part is made on my old printer. So my current printer has got parts made on my old printer, so it's been carried forward. So the old one's not totally died; it's still there. But this is, you know, it's got heated beds, you know, so you can print ABS and the likes, of PETG, which is you need a heated bed for. The instructions are absolutely amazing. When I bought this, it was about £800. It's now down to around 600. You know, if you buy it as a kit form, you can put it together in maybe 6 hours. My 10-year-old son's been putting this together with it, the second printer, and you know, he's not needed much in the way of help from me. So it is a super simple printer, but really capable, and the quality it can produce is pretty impressive. So once the printer was built, I went and printed off all the parts off the GitHub. You can still see it's got the Open Bionics logo on the back of the hands. These are all the parts, all the white and red parts are all the parts you need to build the hands. The red parts are a flexible material, so they move around and flex. I've got a part here. There you go. So this is the segment that's just sitting there holding the things together. Sorry?
Do you cycle your camera? It at least on my screen, it froze.
Okay, can you see me now?
Yeah, it's still frozen.
Okay. All right, well, I'll move on. If the camera's frozen, I can come back to that a bit later. Hopefully it'll unfreeze in a moment.
All right.
If I do that and that, does that work?
Perfect. We can see you moving.
Cool, excellent. All right, that's good. So that's, like I say, that's the red part just in there and it holds the fingers. This is like the tendons in your hand, and it's a flexible material. It's 3D printed. So that's, you know, that my old printer, my old Mendel printer, wouldn't have been able to print that. So again, that was one of the reasons for the upgrade. So you can see all the printed parts there. You can see the 4 motors that are in the back of the hands. and they sit in these channels here. And what happens is those motors. Where's my? There you go. Those motors, they kind of go in and out. So like a linear motor, they go in and out. You supply 12 volts to them in one direction, and the motor will power out and to the end stop. You apply 12 volts in the other direction, the motor will power back. You take the power off at any point in that motion, and it will stop dead. So you have finite control of where the motor positions to. Also inside the motor, it's got a potentiometer. So using that potentiometer, you can decide where the motor position is, and then based on that and the software, you can then stop the finger at any given point in its movement. So all the plastic parts, the motors, they're the expensive parts. They're $50 each, maybe a bit more now with the exchange rate. And then you got some brass bushings here. And what you do with those is in these holes, you can see around the 3D printed parts. You don't really want to screw a screw into a 3D printed part because it's just plastic. It's just going to come apart really easy. So what you do is these brass inserts you put on the end of a soldering iron, and you melt into the hole. So the hole is slightly undersized. You melt that in. It gives you a nice screw thread that you can then screws into. So all the parts here all come together and get used. So this is the 3D printer printing out the socket, which is the bit we attach to Caden. So one of these, as you can see, it's got 5 hours and 45 minutes left. You can see remaining on the print. I thought to myself, this is great. I'll go to bed, and in the morning I'll have my part. Sadly, that didn't work out like this. The bane of a 3D printing person's life is failed prints. Obviously, you know, some hours after I went to bed, it popped off the print bed and left me a bit of a spaghetti nest. Thankfully, it printed enough of the socket that we could test it on Caden, and you can see there we tested it. It wasn't quite right, so we ended up printing a new one. But you can see here it's like a kind of elbow around the back of the support around the back of the elbow. You can see his socket just kind of his stump, sorry, sits just in the end of the socket here. So the idea of this was to give Caden something that fits to him and fits well and gives us a flat surface to then build off of. And the idea was that we have the hands and we have that connected to Caden, and then in the middle we can do what we want and, you know, decide what we're going to do. So this 3D printed part was designed by my eldest son, Macaulay. He's a bit of a dab hand at doing 3D design. And he designed this. Basically, we took a Caden's socket that had been put together at Roehampton, and we took a air drying clay mold of that socket and gave it to Macaulay, and he literally just freehand drew it and tinkered and played with it. And unbelievably, the first one was too big, the second one was too small, but the third one was just right. So it was a bit of a Goldilocks kind of thing, that version 3 fitted like a glove. To the point where Caden said it fitted better than the one that the hospital had taken a mold of, which is quite impressive when you think about it. It was, you know, 3D printed. It was hand drawn from just looking at a lump of clay in front of him, and that part there cost 80 pence to print. So you know, which is not even $1. It's, you know, a phenomenally cheap way to produce a socket, to the point where the hospital are now interested in buying a printer and copying this. And we was in talks about putting this together just before all this COVID thing kicked off, about the hospital in Liverpool and the one at Roehampton getting together and producing something using 3D printed parts, opposed to, you know, taking the molds that they normally do. Not just to reduce the cost, but it's easier to, when Caden's been growing, rather than him having to have one that's too big and grow into, we've made this correct size. When he grows and he says it's a bit tight, all we do is we go into the 3D printing slicing software, which slices the model, and just make it 2% bigger and click print again. A couple of hours later, a new part pops off the print bed. We give it to Caden, and we know it's going to fit because it's the right shape. And, you know, it's just needs to be made slightly bigger. Again, 80 pence and a few hours work, and it's done. Whereas otherwise, he's got to make a special trip to the hospital, a prosthetic, not surgeon, I forgot what they're called now, the technician, the prosthetic technician, will take a mold, and then that will be taken away and then produced into the arm, which then Caden will get some weeks later. So, you know, and that's the expensive part, whereas this is dirt cheap. So we had a way of doing it. So all the 3D printed parts, one of the talks I gave a little while ago, they said how much it will come to. So I've put a slide in now that shows this. So the molds will come back to you, but the parts for the hands, so all the white plastic you see earlier, a spool of that that filament is 21 pounds. And if you look at the weights and how much we use of the PLA, we're actually only spending £5 or just under £5 worth of plastic to produce all those parts. The flexible filament, it's a bit more expensive for a spool, but we're only using 20 pence of it. I've still got, you know, 3/4 of a spool sitting in my bin up there, ready to go next time. So to make all the parts for the hands, it's just £5. So $6-7, I think, to make all the parts for the hand. Chuck in the socket, another 80 pence. You're talking, you know, £6, maybe $7.50, $8. The molds, if I show you one of the molds here, this is the mold that molds the palm of the hands, and the palm sits underneath this white piece here and screwed down, and then we pour a material in here, which is used mostly in the film industry, really, for producing like the mask. If you want to be a Klingon or something like this, they use this urethane kind of stuff that they mix up. You can get in different colors. I got it in black. You pour it in there. You push the plunger down. It squashes the goo in around the hands. You leave it on the side for 16 hours, and then you'll kind of take the part out and hope it's molded, which is good. So you make the molds. I made these molds. I printed those molds out of PETG, which is why it's slightly more expensive. But I've probably made about 10-15 hands now using these molds. If you can see, if I hold up my test one here, you can see here I've used a black urethane rubber and molded it on. So you've got one for the thumb, one for the palm grip, and then one that does the fingers. And these here, it's like a soft, squishy material. Normally, if I'm doing in person, I hand this around for you to have a feel, but it's like a squishy material, and it's got quite a bit of grip. If it was this hard plastic, it's quite slippy. So when you try and grip things, it just slips out your hand. Whereas this kind of grips. It's like it kind of if you use like kind of gardening gloves that has that neoprene bit on the end. It's a similar material to that, so it allows you to grip. So, you know, we're down to, you know, not a lot of money to produce these parts. And adding it all together, if you're only making one, you're talking £15, $20 for the 3D printed part. Obviously, the printer is expensive to start with, but we're still well under the cost of what the NHS are paying just to produce the arm for Caden without the hook and other parts. So then we come to control. So obviously we've got these 4 motors in the back of the hands, and we want to control it. Now, Open Bionics had this Arduino compatible board. It's got an Atmel ARM processor in there, the M0, you can see in the center. It's a home-baked board. They called it the Chestnut. So it's their own design. They have them made. They did sell them on their store, and they had an online store where they sold them. But this is, you know, it's a bespoke board. They sold them for £250, and I waited many months to try and buy one. I was on the kind of waiting list. It turns out what they were doing was waiting until they had enough orders, both internally within their business and externally from the likes of me, and they're just getting batch built, and then they get the batch in and sell a few to, you know, likes of myself and others around the world, and the rest they keep themselves for their production line. So you could wait months, which concerns me, because if Caden got this wet and it, you know, blew up the board or something happened to it, it'd be months again before we could get a new one. So I was starting to, it's okay, I like it. I did look into getting my own ones made, but the cost was, you know, quite high. It was considerable. It wasn't something I was prepared to do, but you know, it's a good board, and we could use it. How did they control the board? How did they tell the motors what to do? Well, they use these MyAware sensors. You know, as you can see in the image there, I've got one here. and these have these little little pads, just like EMG pads. So when you go and have your heart rate done at your doctors, they just stick on your skin. And then the MyAware sensor takes a reading from the muscle tendons and the muscle mass. So you can see here, you have the different positions of the sensors. This is from the MyAware website. And you need to get the kind of in the center of the mass of the muscle, and then have the fly lead, which is the bit that comes off, needs to be on hopefully a bit of bone somewhere where there's no muscle, and then it compares the readings between these two pads and that pad there as a kind of null reading, to then give you a muscle reading. And the correct placement, you should get a lot of kind of muscle movement noise, but that means you need to stick it to the skin. Now these pads, they're only going to last one use, because they'll peel off the skin. And so every day he's going to need 3 pads for each sensor. To make the hand work correctly, you need 2 of these sensors, 1 each side of the muscle group. So that's 6 pads per day. You can buy a pack of 50 pads for £5, but you're talking that's only going to last for 7-8 days. They're not expensive. They're £5 for a pack of 50, but that's a cost going forwards that the family have got to bear. Now, Caden's family living in a Western country, it's expensive maybe, but to other parts of the world that I visit where I'd like this project to go, it is cost prohibitive. So it was starting to play in my mind. Actually, these are ongoing costs that I don't want to have. So where do you position the sensor? Obviously, for you or I, if we've got a full arm, we can stick up the muscle there. This is not a drawing of me. My muscles are nowhere near as big as that. But you can see where you'd stick the pads. It's kind of electronic unit. Now these are £35 each. You need 2 of them. They might break. It's just a fragile bit of board. So sticking them on a young child is probably not a wise idea. But how do we do it? Well, like I say, if you stick them on the muscle group, and then the black dot there is the fly lead. So you stick it on the elbow or a bit of bone area. But if you, I can't see you all on the video at the moment, but when I do this in a room, it's really good. But if you hold your arm up like so, and you get your 2 fingers like a claw either side of just above your elbow. If you then put your hand out, so open the grip, you can feel the muscle at the back there goes tight, and the muscle at the front you can't really feel too much about. If you then close the hand towards you, you can feel the muscle here inside goes tight, and the one at the back goes slack. If you put it up and then grip and create grip, they both go tight. So the way we control this is we have open, close, change grip. Yeah, so we have 3 inputs into the sensor. So we have one muscle sensor saying it's tight, and the other one's not saying anything. That muscle sensor is now saying it's tight. That one's saying nothing. They're both saying they're tight. Okay, now we must do something different, which we've used to change the grip in the grip sequence, to move to the next grip in the grip sequence, rather than the button they have on the back of the hand on the Open Bionics board. So that was, it's quite good. But obviously these sensors, the boards are quite expensive. The pads are quite expensive. I'm chalking this up as, yeah, it's good, but I'm going to look and see if we can do something better. It's not moving on for some reason. Are you still there?
We're still here.
Yeah, I don't know why my slides are not moving on. I don't know why it's not moving on. Oh. There we go. So I've just shown you open and close. So the grips that we have in the grip sequence that are loaded into the software of the hand. So you've got a fist grip, palm grip, which is for holding the shopping, the carrier bags. Caden asked me to remove that one. He didn't want to help with the shopping. Yeah, we've used something else there. We've got a tripod grip, which is for holding a pencil or a pen. Pinch grip for holding small things, the point gesture, it's over there, mate. If you want to tell your friends where you're going. See, now my computer's catching up now. So they're the grips that load into the grip sequence, and these are all ones that Open Bionics have done some payload testing on, and what they can do. Now those are written in software. So in the Open Bionic software that's loaded onto their chestnut board, they have a 3D array that make up these grips. And I've put hopefully you can see it there on the slides. I've basically cut and paste this 3D animation array out of the software. You can see there we've got, so we take the fist grip. F0 is the thumb, F1 is the index finger, the middle finger, and then 3 and 4 are basically the last motor, and it does both the small fingers. They did, when they designed it, originally have a motor for each finger, but then realized quite quickly actually those two always move together, because very rarely do you move these fingers independently, but you do move the others independently. So they've tied 3 and 4 together. So you have an animation timer that runs, they originally had it for 2 seconds. I think we've got it at about 1.8 seconds, somewhere around there. And it basically, over that time, it counts from 0 to 100. And as it goes down this array, from 0 to 100, when it's going from 0, it reaches 10, it looks across and see, oh, okay, I want to put F0, which is the thumb. Slides are going everywhere. F0, which is the thumb, I want to move it to position 750. Now, it goes from, the motors move from 0 to 1000. So 750 is about 3/4 of the way. But do nothing with, now my mouse has gone weird. Do nothing with F1, F2, F3, and F4 because they're blank. So do nothing with those. So they start fully open. And then at 40% of the animation timer, you're keeping the thumb at 750, the other's blank. And then 100%, between 40 and 100, you want to move everything to fully closed. So that means that the thumb will come across most of the way, and then the rest will close around it. So you end up with the thumb coming across and the hands closing around the thumb. Or in this case, it does this to create a fist grip. So that's how the animation timer works. Now, you and I, as software engineers, we can understand that. I've explained it to you fairly quickly, but I'm pretty certain that, given 10 minutes, you'd work this out really well and understand it, about make umpteen grips. So you want, rock hands, whatever you want to do, you could work it out and do this. But for us to do this, you need to go into the code. So open up Visual Studio, VS Code, the Arduino editor, go in, find the animation array, make the edits you want to make. Make sure you're happy with them. Then you need to upload them to the board. Then you need to mechanically and electrically test them. And then you need to go and give it to the child. So that's a lot of work just to change a grip. And the other thing is we start off with fist grip, and then it's palm grip, thumbs grip, point, pinch, tripod grip. And then you go back around the sequence to fist grip. So every time Caden wants to change grips, he holds his fist closed for more than 400 milliseconds. And it's like, oh, okay, right, I want to change the next grip in the sequence. And he releases again. So now it's palm grip, that's thumbs grip. And do you know where you are? Because, it's quite easy to forget. And if you've been doing something else, your mind's been elsewhere, he's like, well, which one's the next grip? I can action it and then see what it is. And no, that's not what I want. I need to open again and then change the next grip, because it'll only change while the grip is opened. So it's quite confusing. Maybe he's at school and he's not going to really need the palm grip for carrying carrier bags. He's at school, but he wants a grip for being at school, a special one. Maybe he's at home. One of the grips that he's got loading onto his hand at the moment is to hold the Xbox controller. So he can now play the Xbox with his friends. And he's got that grip because we edited the array and made a change for him. But I wanted this to be able to be done such that you didn't need a software engineer with a laptop and all the special cables, etc., to be able to change grip. So I'm thinking, well, I want to be able to change this dynamically with an easy to do device. I forgot I had it zoomed. So you tell I've talked about a few of the drawbacks coming through. So the processor board was, single source supplier. If Open Bionics disappear, then my supplier disappears. They now have closed their store, so even if you wanted to, you can't buy the board anyway. It's expensive for an IoT board compared to others. The malware sensors, the muscle when Caden started with this was quite weak, so the readings we're getting were really low. And then what you have to do over time is there's a little potentiometer on the corner of the board. You have to get in there with a small screwdriver, jeweler's screwdriver, to change the gain levels and move them up a bit. So that means taking it apart. Obviously, electronics being stuck to a child, it's going to break. And I talked about the pads as well. Grip sequences. Maybe Kaden wants his own grip. He wanted one for his Xbox. So, you know, there are some drawbacks. I thought to myself, well, you know, I had plenty of time sitting at 43,000 feet doing 600 miles an hour. I'll think through these problems, and I took these problems away in a notebook and, you know, thought, how can I work these out? Now, I use a lot of IoT stuff and I get a lot of things from Adafruit. They came out with a Feather board a year or two ago, as you can see there, the Adafruit Feather, based around the Atmel chipset as well, the M0. And on the end here, the red lump you can see on the end is a Bluetooth connection. So I thought to myself, well, hold on, I can use the software that is loaded onto the Chestnut board, because a very similar chipset, you know, so I can copy that across. It needs some tweaks, but yeah, that could work. And now I have Bluetooth, which means I can connect it to a mobile phone, which means I can now start to do things. 3.3 volt boards. It was, you know, relatively cheap. I think they're £18 each at the moment. So yeah, relatively cheap, not 250, and I've got full control. And you know, this processor is actually slightly more powerful than the one that was used on the Chestnut board. You know, it's a standard USB connector to connect to the board to do any uploading and downloading. And they've got a JST plug, which is that big black box bit in the corner for plugging in a battery. So some of the specs of the boards, like I say, it's a similar Atmel chipset. On the fourth line down there, for some reason my mouse has decided it doesn't want to play ball anymore. You can see there's no EEPROM, which come back to bite me a bit later, but I've managed to find a way around that. But it's got enough PWM pins, so pulse width modulation for controlling the motors. It's got input outputs. You know, it's got all the hardware serial and I2C serial ports for connecting to other boards. So this, you know, it's a good contender. And at £18, I literally bought it from Amazon. It arrived the next day. It's that cheap and that easy to obtain. So again, getting around the problem of single source supplier. These things are being sold around the world from any electronics hardware place that you can get these parts from. You can get them even Amazon, eBay. So dead easy to get hold of if you need them in quickly. So I took the boards. The other board that you can see next to it, the one higher in the image there, is the Adafruit Feather motor controller board that allows you to control either 4 motors, separate motors, or DC motors. Obviously, I'm using DC motors, so they're wired up there. And then there's a board underneath, which is literally just a plain board I've used to build up the circuit. I don't use it in the hand anymore because it's a part that isn't needed, and it was just to help do the connections between the two boards. One of the problems I had, as you can see in the picture on the right hand side, is the motor controller board has got through-hole pins and the FTC cable on the end of the motors, the flat ribbon cable. Obviously, you can't connect the two together, so that caused me some problems, which I managed to resolve by finding some connectors eventually. But that took a few months to find connectors to connect that into the through-hole cable in the end. Now, believe it or not, you buy the motors from Actuonics and they come with that connector free of charge. I spent months looking for the connector and I now give them away. So I connected all that up, and oh, my mouse is back and my keyboard's gone again.
Hey, Clifford, can you cycle your video camera again? It froze up on us.
Am I frozen again? There we go.
There we go.
Cool. I'm not sure why my slides not working now. I think I'm asking too much of my laptop. Poor things. Come on. It does want to play. It's completely frozen. I'm going to go full, shut it down, kill it. Doesn't want to give me that either. Here we go. That one there. I'm completely locked out of my computer. Oh no, this is not good, is it?
Turn off your video cam. I know it's GoToMeeting. It drains a lot of your power.
Oh, hold on. I've stopped sharing. I didn't want to do that, did I? Click the wrong one. There you go.
Full screen again, you're not able to move it.
No, it's not allowing me to do anything.
Do you want to try rejoining the meeting?
I'm just going to stop the slideshow and see if that's let me stop sharing for a second. Apologies for this. It's just decided that it doesn't want to play ball.
This is what happens sometimes with these with the online user groups. It's understandable.
Well, I've had it do it once in you know, real life kind of. It's just not working at all. There we go. I think I'm back now.
Are you sharing your screen?
I will do shortly.
All right.
1 second. And then I need to. There we go. Excellent. Just need to catch up where I was now. Hey, there we go. Right. So, like I say, I think I've got it all back now. I think it's just, yeah, my computer is just, yeah, struggling, I think. But you can see these little connectors at the bottom. Sorry?
I was gonna say, if you need to show us anything, I would just turn your camera on for that and turn it off just to make sure.
Yeah, I will do. Yeah, yeah. I think that must be it. But yeah, I got these little connectors at the bottom, and I needed some. You know, I was trained when I worked in engineering. I spent a couple of weeks being trained how to use soldering irons and doing fine work under microscope. So that needed quite a bit of effort to solder these kind of, you know, flat ribbon cable onto the end. But I'd been trained to do it, so you know, it's another thing I put on my to-do list to resolve. The new connector I've got is much easier to solder to, so you don't need to be, you know, as highly dexterous with a soldering iron to connect these on now. This here, Pololu power control module. So this takes in the 12 volts in the battery and steps it down to 3.3 to control the boards. So I provide 12 volts in here, which goes across and feeds the motors. So you can see the black and red cables coming across, and that feeds the motors because the motors are 12 volt DC. Now step down that 12 volts down to 3.3 to control the boards. So I've managed to cross off the processor problems, which is good. That was a nice thing to cross off. Next thing is the sensors, these malware sensors. I read Hackspace magazine. I'm not sure if you can get it in the US. It's a fantastic magazine made by the Raspberry Pi Foundation here in the UK. It just keeps going back now. I was flying along somewhere over middle Russia, off towards Japan, and come across this Arduino debugging article. It's a great article written by Graham Morrison. The bit that interested me was, I'm wondering, it's my keyboard, you know. A bit that interested me was this sensor in the bottom right. He was using that in this article, and basically this is a piezoelectric sensor, a bit like the buzzer that's in all your PCs. You provide a bit of electricity and it gives you a buzzing sound. This one, you provide pressure or vibration, and it gives a very small amount of electricity out, but enough to measure. He was using this to talk about Arduino debugging. So I landed, couldn't wait to get near a computer, and ordered a pack of 10 of these from Amazon, and they beat me home. So I flew all the way back, and they were sitting there waiting for me. A pack of 10 cost less than £1. I think it was like 87 pence or something like this. How Amazon managed to get these from wherever they were made in the world and ship them free of charge, Amazon Prime, to my door for that amount of money, I will never know. But hey, they were great. So I fitted these into Caden's arm, took it round, he tried it, and he said, this is great, but I can now only open and close the arm, whereas before I could stop in the middle. with the malware sensors. So it's like, okay, well, we've got cheaper sensors that actually work, but now we can only open and close. We can't kind of stop halfway through. So we lost a bit of control. And like I said earlier, Caden was very critical and pointed these things out. Yeah, we're moving along the right way, but we'll see what else we can do. So I then stumbled across these force sensitive resistors on SparkFun. And as you can see there in the GIF, as you apply a force, you can measure that force. And the harder you push, the more the resistance changes. And then what you do is you pair that in parallel with a normal resistor. And depending whether you go with a 3 kilo ohm or a 3 mega ohm resistor, depends on how that resistance bridge works. And then depends what the voltage is and the ramp up and down of that voltage that you get on your analog input. So I tinkered and played, and we eventually settled on a resistor value that worked for us. Certainly worked for Caden anyway, and that's what we're now using. These sensors, as you can see, £6 for two. For the small ones, we actually worked out that the slightly larger ones, which are a square in shape and about twice the size, actually work a lot better. They're about £8 for a pack of two. But again, not very expensive, certainly cheaper than one of the malware boards, and we don't need to change the sticky pads. They're literally glued on the inside of these socket that you see earlier. And the bigger ones actually have a sticky backing on them anyway. So that solved that problem. So here's the fritzing circuit. You can see the bridge here with the resistors and the two sensors. You can see the two boards, the 4 motors. Fritzing didn't have a rectangular motor, so I just used this one. And then you can see here, these are the two Polylu boards. That's the one that steps down from 12 volts. And then we have another one here, which what I'm doing here is Bionic use a battery pack out of a radio controlled car. So it provides 14.7 volts, and then they step that down to 12 using one of these Polylu boards to provide the power to the motors. But that's quite a heavy, bulky motor, battery, sorry. And it's a bulky, awkward shape to put in the arm. You need a specialist power supply to recharge the battery. And it wasn't ideal. I used it initially and it was like, yeah, this is okay, but we could do better. And when I was searching for a completely unrelated project for a client, we need to step some voltage up. We just need to get up to 9 volts from a 5-volt battery. We could have used a PP9 battery, but we didn't want to go along that route for various reasons. But I see the fact they did one that stepped up to 12 volts. So I bought one. I think it was about £6.50, and plugged in a power bank, just like you must have a few of them kicking around in your bag on your desk. Just a normal USB power bank. And I was getting a stable 12 volts from it. I could drive the motors from it. So now I've got literally an Anchor power brick that costs £20 from Amazon, and that is the power supply. So he can now charge that using any USB power supply, which they're commonplace now. Teachers will have them in school. He's got loads of them around his house. Downside is though that when his friends' batteries go flat on their mobiles, they ask Caden if they can in an hour or two with the cables and a bit of soldering, and I've built a few of these now. So, someone who's not built it before, probably 3 or 4 hours work. You need to be not spectacular at soldering, but you just need to know the difference between a dry joint and not a dry joint, and be able to use it for soldering iron, and you should be able to build this quite easily. Oh, it's frozen again. No, oh, there you go. So we crossed off the malware sensors. So now we moved across the Bluetooth. So now we've got the hand working. We've got all the sensors and electronics working, and Caden can take off the software from Bionic, run it on the boards, and go away and use the hand. So that was great. Now we come back to the problem where I said that we want to be able to control the grips. Like I say, I'm a freelance Xamarin developer, and I wanted to put a bit of Xamarin love in there as well. We had Bluetooth, so we used the Bluetooth module. Anyone that's worked with Bluetooth knows that there's umpteen different acronyms and different ways of calling it Bluetooth, smart Bluetooth, etc., classic, that sort of thing. So, breaking that down was the first barrier. I hadn't really used Bluetooth too much in the past. But yeah, the boards use Bluetooth Low Energy. So basically, what you do is, if you haven't used it before, you have a peripheral device, which in this case is the hands, and then you have central device, which is the mobile phone, and they just communicate. So the central device, the mobile phone, talk to lots of peripherals, maybe your smartwatch, your car, that sort of thing. But the peripheral device only talks to one central device. The low energy is quite clever. The master, the peripheral device, sends a command, and it says, we'll talk at this interval and the connection interval, and the slave sends a response, and then waits the next connection interval before it turns back on again to listen to the master. So that connection interval is agreed up front, and they then talk on that timing sequence. And then that means that it uses less energy because, and hence the name low energy, because it's turned off for a large chunk of that time. And depending on how much control you need, you can open and close that connection interval. So we've got it open quite a bit because we don't actually need to be talking every 10 milliseconds. Every couple 100 milliseconds is more than enough for what we're doing. So we can have it open quite a bit. Oh, come on. This is going to drive me nuts. Not sure there's much else I can turn off. You know what? I'm going to unplug this keyboard just quickly because I think it might be that. Can you still hear me?
We're still here, and these things
Okay.
happen. Don't worry.
Yeah. I'm burning up my CPU. I don't know what I'm doing it on, but it's burning up on something. Something's really chewing it up. But yeah. Right, let's try that one because that one worked earlier, didn't it? There we go. All right. So obviously, I'm just aware of the time with all this messing around. In a Bluetooth packet, you have the profile, which is the device talking. Inside that, you have a service. Inside that, you have a characteristic. So your profile will be the profile of maybe your Bluetooth watch or handy. The service inside that would be, if we go with your smartwatch, could be looking for your heart rate data, and then the characteristic will be the actual the data that's sitting within that. So that's kind of how it all breaks down. Now I'm hoping I can get across to Visual Studio. There we go. So in the Open Bionic software, I then started to I forked the software and started to hack about inside, so it fitted onto the Adafruit board. But one of the bits I did do was obviously putting together the Bluetooth. Now Adafruit produce libraries for all their boards, and one of the things they do is produce a Bluetooth library, which allows you to connect to the Bluetooth, and the setup is dead easy. You literally tell it you want to begin the setup. On my test device, I do a factory reset every time. I have a brilliant setup here. And the reason I do that is just so that I know that anything I've been messing around with while I've been testing gets completely wiped. There's no old settings in there. I then give it a device name, which I call Handy. It seems to be a name that stuck from Twitter about a year or so ago. And I don't want it to echo back any of the Bluetooth commands, so I turn that off. And then I set up the timer while it sits and waits to connect to the mobile phone. So I just allow it to connect. I give it 10 seconds to connect to the phone. If not, I allow the hand to go off and do its own thing. So it's a bit of a blocker when the hand starts up for 10 seconds. and you have that 10-second window to connect the mobile phone. That is something I've tinkered and played with, but every time I've done it such that it can connect to any point, it seems to interfere with the pulse width modulation signals because the timer intercepts get in the way, and it means the hand stops mid sequence. So it's still something I'm playing with and trying to resolve. But at the moment, you got 10 seconds from turning the hand on to connect with a mobile phone. Yeah, it's connected. I then go back, I set some LED activity lights to what I want them to be. And then literally all I do is I poll for Bluetooth, and that's called out in the sequence timer. And the Bluetooth's enabled because we've proved it up there, and there's data collect. We read that into an array, and then we iterate over that array and do what the data says. But if we want to print something out from the hand back out to the app, it's just literally Bluetooth print and then a string or a value, and these are just standard print functions that are part of any of the string print functions of the command line. But you print it out to Bluetooth. So Adafruit have taken all the hard work out and made it super simple to read these values and print them out. And that is it. That is the whole of the Bluetooth library that I've had to do, all because Bluetooth Adafruit have done the hard work for me. So that is how we connect, and you've got the interrupt signals and chip selects and stuff like this that you need to set up as well. And then within the Chestnut board, what they had was you could plug in the a USB cable, and then using a PuTTY or some other serial login terminal logger, you could send serial commands to and from the hand for setting it up in the factory or in the hospital setting. So all I did was hijack those and ported them via the Bluetooth. So now the Bluetooth signal can send and receive those exact same serial commands. So I didn't need to rewrite a new serial system for Handy to connect to Bluetooth. I just said, well, instead of connecting to a serial port, just connect to the Bluetooth port and send all the data backwards and forwards over that port. And that's all this method is doing. So it was, a day's work, and got it all set up and working. And now I connect the phone to where's it gone? There it is. I connect the phone Bluetooth to the hands, and then using Adafruit's serial app that you can download from the App Store, I was able to send the same serial commands to the Adafruit board via the Bluetooth app, which then meant I could control Handy and sort of thing. So I was like, excellent. I now have control of the hands using just serial commands from an app. So now let's make my own app. I use Xamarin. I know, love it. I'm sure you guys have used it as well. So I'm not going to labor this too much. But I do a lot of C#. I know that Xamarin allows you full access to Bluetooth stack. So I picked obviously the Xamarin. Just when I was starting this, you obviously got the traditional and Xamarin forms. It's more, I'd say now in the last year and a half, 2 years, more people have come across the Xamarin forms and traditional Xamarin, just because of the shared UI. Draw it once and it's going to look the same across all the devices. It did used to be until about, I'd say even as early as 6 months ago, the Windows logo really didn't exist in Xamarin's forms. But I think with the new Duo and Neo coming out later this year, I think Xamarin and Microsoft have now started putting a lot of effort back into UWP. Certainly, even Shell now supports UWP as of a month or two ago. So, Xamarin Forms seems to be taking over more and more. So I went with the Xamarin Forms. The other thing at the time was Xamarin Forms Shell was new, and I wanted to learn it, and this was an ideal project. So I went across to Xamarin Forms Shell. Now, does anyone use Xamarin Forms Shell here? I'm not sure if I can see the a little bit. Oh, okay. Well, Shells, if you think about when you do start a new Xamarin Forms app, you got the master detail, you got your tab view, though, but you still need to worry about and sort the navigation out. the amazing thing about Shell is the fact that all that is abstracted away. You tell it that you want a flyout item, and that gives you the master detail or the flyout pane that comes out from the side of the page. You then tell it that within that flyout item, I want some tabs. I want the icon of the tab to be, a hand pointing up, and I want the content of when you tap that tab to go to the control view. So that there is my navigation. That's it, done. I don't need to think about or do anything else. I don't need to cut and paste those elements from a blog post or from the docs.microsoft about how to do all the navigation stack. I don't need to think about the navigation. It's just done for me. I then, if I wish to navigate, if I go into one of the view controllers. No, I wanted the view model, not the. What do I want? Go into the Bluetooth view model. To navigate to the next page, it's just simple as that. Shell.current.navigation, pop to root, which will take me all the way back to the beginning of the app. So it's dead easy. If you want to go to another page in the app, where am I going to? I'm not sure if it's in here or not. I had all this open earlier. I had to close it down. So that's where I'm sending the commands. So Bluetooth service, sending the UART commands out. It's not in there. I've lost the page I'd open. Anyway, it's basically all you do is that shell.current, you send it out to, you send it a command and say, I want to go to this page within my app. It will then, because it's got the navigation stack there, it will add that page into the stack. So you can still pop and push onto that stack as you normally would with navigation, but it's a lot easier. Allows you to do that all within the shell. If you have a page which isn't in the shell, it's not part of your front navigation, then within your app.xaml here, you can, actually I took them out, didn't I? I took these out the other day. This is why I'm not able to see it, because I did take them out because I did it differently. Yeah, that's annoying. I shouldn't have done that before I talk. I apologize for that. But what you do is you set up in here a routing to that page, and you give it a name which is unique for that page. And then when you push that page, you'd say go to this and the name. And then because that name has been given a route in your app here, when the app starts up, it then knows what that is to go to. I took them out because I didn't need them anymore, because I put them all in the menu structure of the app. So this created my app, allowed me to send the Bluetooth commands. So in here, I'm using the BLE structure, or sorry, NuGet plugin to pull in. The reactive bit was a bit difficult for them to grasp at first. So I then went back to using this BLE plugin, and it just meant that it's a little bit easier for a new person to grasp than the reactive, because it is literally just kind of methods, and it's a lot easier for them to grasp. So that's what I've kind of moved back to from Shiny, even though I really like the way Shiny did things, but but I do still bring in things like I've forgotten who's it? He's one of the Toronto guys, isn't he? That did the Shiny. Alan Ritchie, isn't it? Yeah, amazing. I owe the guy so many beers. But I use his plugin for doing the dialogues, his ACR stuff for doing the dialogues, because I think it's an awesome plugin, rather than bringing in the whole Shiny set for doing that. So you can see here, it's fairly easy to lay out and send the Bluetooth commands across to the hands from the device. So if I now go to the hands, where's it gone? So you can see here, as it's opening up. Now, if I connect the hands, and you're going to want to see this, aren't you? I'll turn the video back on. So you can see I'm just using Anchor Power Brick. there's the 12-volt module in the corner, and then if I connect,
We're on your
start
other camera.
scanning.
We're to your right.
Are you on that one now? Yeah. Oh, okay. Hold on. I can change that. What's happened there? How do I change that? There.
If you hit the settings option, that
Yeah.
you should be able to go in there and change the video.
Oh, it's unclicked that camera totally. Right. Okay. I think it's my Logitech camera must have been causing a problem earlier. If that was freezing, that might have been what was causing the problem, because it's now disappeared from my my list. So I'll use this camera over here, the backup camera. So you can see I've got the anchor power brick and the 12-volt. So it takes 5 volts from the power brick, and that's nice and light and easy to stick on the arm. If I step it up to 12 volts, which then controls the arm. So if I power the hand on, when you boot up the app, obviously using the permissions, the Xamarin Essentials permissions, because I've just installed this app a moment ago before we started to talk. You can see here it's asking for the permissions to give the app permission. So I want to give it the permissions to do what it needs to do. And now I've got the permissions. Allow permissions. It needs location for Bluetooth to work. So now you can see it's now searching for all the Bluetooth things it can find. And if I plug in the hands, and there you can see Handy has appeared, and I can connect to Handy, and it takes me into the application. So I'm now in the application. If I now go to the UART commands, you'll see it's connecting to the hands, and it's talking via UART. Because this is my test development hands, I need to go into the UART, and in the background of this page in the Xamarin app, it's doing a few things, connecting to the hand and doing some handshakes, which Caden's arm doesn't do because it doesn't need to. But I'm using it for sending some data about the boards back for monitoring. So now I've got full UART, just like they have with Open Bionic. So I can tap in the commands here. So G0 is grip 0, and hopefully you can see the hand moves. So they'd send that, and then send it again, and open the hand out, and hopefully you see that. If I do that, you can probably see it a bit better. So that's the fist grip. Oh, without breaking my laptop. So I'm doing that using the UART commands. But what I wanted to do was not have Caden sending kind of text signals of everything else. So building the UI out. This is I'm having no luck with the keyboard won't disappear. No luck with tech today. It's a demo gods have got me. So what I wanted to do was have all the grips that Caden's got loaded into the hands, nice and easy to use. And then if he selects the heart in the top corner, that then says that's one of the ones I want to have in my grip sequence. Or I'm not sure what that grip is, so I'll just tap it and it will send the command for me and open and close it. Maybe I want that grip, which is the carrier bag grip, or I want to do that one, which is point. It's over there, mate. So they're the kind of putting that together gives him easy control of the grips, and then there would be buttons at the bottom, but there you go, the keyboard's gone now. So there's the grip order. So this uses it's just a list view, and I've used I've got to say Alfonso's. I'm going to butcher his name, so I'm not going to try. But he made a plugin called Sharpnado. And one of those is the fact that you can have a list view, and if you hold it down, you can then wield a list view, which is, I was using a Sync Fusion control before. He's put one out, which is Sync Fusion was free because it was open source, but this one doesn't need a Sync Fusion license, and again makes it a lot easier. So now you can change the order you want them in, and you can see only the first 3 have been selected to be part of the grip sequence. The other ones are grey. So now I can save that back to the hands. Now Caden, when he grips, has only got 3 grips loaded into the hand, and he can now decide that I want to have those grips as my 3 grips for today. I get home from school, and now I want the Xbox grip, which isn't loaded in my pack here. I want to put the Xbox grip on and get rid of the other ones because I only want the Xbox grip. I don't want the other grips in my hand. So therefore, if he accidentally clenches his fist because he's angry that he just lost the battle in Call of Duty or whatever he's playing, he's not going to accidentally change the next grip and lose the next battle as well. So you can see, just simple UI changes. Grip builder. I'm not sure. Can you see this, or should I try and make it a bit bigger? Is that going to work for you? There you go. Is that big enough? Yeah. Yep. So you can see here, grip builder. So the idea here is, and this is something I've been working on, is the fact that you've moved the slider, and you can see here the animation time is at 0. So that's where they'd start out at. You'd add that, it'll add it to the animation timer. You've moved the animation timer up a bit, say to 40, and then say right now I want that finger to be there, add that. And then once you've built the sequence up, you'd save it, and it'd save it back to the memory within the hand, and then it becomes a grip on the grip sequence. So then you can add it in your grip sequence here. This is how we built out the Xbox grip, was playing with that tool there to allow Caden to build out the Xbox grip, so he can then control the hands and add grips as he chooses. I've been told, added a rather rude grip to tell his friends and teachers where to go. But it's allowed him to play with the hands and control it as he sees fit as the user. And the idea is that if I unplug this, can you hear the whining? Can you hear the motors whining? There's the reason for that is the motors in the back, the PWM signal that controls the motors. If I have it outside of our audible range, like as a human being, my dogs go bonkers because it's in their audible range. It drives them nuts. So I tune it down for me so it doesn't drive the dogs bonkers. So if I get rid of visor, because I'm not going to need that anymore, I can close that down and offload my computer somewhat and go back to some slides. So I build all this on my dev machine, and I push it out via App Center. It goes to Caden's phone. He gets an update. He's happy. He then lets me know what he likes and doesn't like about it. And to the point where actually now he's using a private GitHub channel we got just between the two of us to kind of go backwards and forwards. And that's purely because he's still a 15 years old, and I didn't want the stuff he's putting on an open GitHub on the open channel GitHub. So some of the stuff we've been doing backwards and forwards just on the private GitHub repo, but all the code that gets built via App Center is from an open source GitHub repo. And you can see I push it here. It goes out to Caden. He gets it on his phone. He then has a new update of the app, and he lets me know what he likes and doesn't like about it. App Center is great. It's free. It's awesome. If you don't use it, it's totally free. If you want to do more than one build at a time, obviously, that's where you start to pay. I pay for it. I think it's $40 a month. It's not a lot at all. And all my apps that I build for clients as well is within that $40 a month, and it just goes up and builds it. It's awesome. You can see when the app's installed on the user device, if they've downloaded the latest version, what version they're on, the OS version of their device, what their device details are, is it an iOS device, an Android device, etc. Even to the point we can build UWP apps as well now. So you can see now my drawbacks I had earlier, we crossed off the malware sensors, the processor and the store was closed as well, so that's good. And we crossed off the way of controlling the grip. So we crossed off all the problems. I've got an open Bionic hand I started with. I've taken their design, iterated on that, added the Xamarin app, added new sensors, the same motors, and an Adafruit board in the middle, which means that I've managed to get the cost down. As you can see here, without the molds, the plastic costs £5. All the components that make up that hand come to £430. Add a little bit for nuts, bolts, and screws, and a few other little bits and bobs you need. You're less than £500. I'm just over at the moment. It's about 515, but there's a few parts that I'm playing with to reduce the cost. So £500 to build, and that includes the arm in the middle as well, because that's being printed as well now. That's about £1.10 in plastic. So you can see for £500, I've built an arm that Caden's now got, and he uses day in, day out. Well, actually flicks between that and his hook, because he sometimes prefers to hook when he's cooking because it doesn't melt. But for £500, we built an arm, which is quite impressive. It didn't start out with that. It's all running .NET in the mobile app, but the OpenBionics software is all written in Arduino C. So one of the things I did want to do was just sort of challenge, because it come from one of the conferences I went to, was one of the Microsoft guys was like, it'd be really nice if you get .NET in the hands. Well, that's possible now with the Meadow board. Not sure if you guys have seen this, but it's the Meadow F7. So wee little boards, and when they had this on Kickstarter, they touted it as being a drop-in replacement for the feather board, because the pin outs are the same. And you can see here it almost is it's almost the same. It's just this little area at the end, which is I'm not 100% certain what they're using it for, but that little area at the end is the bit that makes the board subtly longer, which means it doesn't quite fit in the back of handy. But one of the things I have been playing with is moving the electronics out of the back of the hand, where they sit at the moment in the back here, into the arm, which then means that we reduce the weight of the hands a little bit more. We're not talking a lot, we're talking a few grams, but reduce the weight of the hand more, which means the moment of Caden holding that kind of up day in, day out is a little bit less. And also means we can move across to a feather board. Gain some other bits as well is the fact that I can do over-the-air updates with that, whereas I can't with the feather board, but the Meadow board I can do over-the-air updates, which is awesome. I can then not only push a mobile app update to Caden, I can push a hardware update to his hand as well, which means I can iterate the two side by side a lot quicker as well. So I mentioned a few times about being a pilot. One of my kind of ambitions now with this project is I've got the price down to such a low point that actually I can put a printer and all the parts needed into a box for £1,500. Chuck in the parts for 3 or 4 hands, you're talking £2,500, still less than one arm for one child that the NHS are currently building for £4,000 or £5,000. Fly to parts of the world that I go, we've been an airline pilot, drop off the box, teach some local doctors and technicians how to use the parts that I drop off, how to build an arm, maybe do 2 or 3 trips down to wherever it is I'm going, and then leave them with the ability to print parts and produce hands for children there, possibly cheaper than what they could produce, and hopefully better in usability than what they're able to produce with maybe just a dumb arm, which is mechanically moved via a bit of cable across the back of the shoulders. So that is kind of why I mentioned being a pilot, and it's something that actually I'm talking with some people in different parts of the world, a team down in Africa and a team across in Pakistan, to actually make this come to fruition. It was planned to try and do it at some point this year, but obviously COVID's put a block to that, so hopefully it's not going to be too long before I can do that. And that's it really. I just want to say thanks to Caden, his family, for being amazing and letting me work on this project and supporting me through it. Caden's been a great help, and if you've got any questions, now's a good time. If you want to jump in and help, it's all on my GitHub, jump in. That's the link to Handy app, but if you go across to the GitHub, it should be here somewhere, there you go. You can see there's 4 files, the electronics app, the 3D files, which are all the OpenBionics ones that I've forked, and they're modified to use. And then we got the socket and arm, which are the extra add-on 3D printed parts that fit for Caden and another child that we've trialed it on as well. So you can see, it's all there, open source, jump in, help. So that's me. I've spoken too long. I had some technical issues along the way. Hopefully it didn't take too much away from it for you. I think if I stop sharing. Is anyone there?
Yeah, we're still here.
I thought you'd all gone. I've been chatting for an hour, man.
No. Thanks so much for that. That was a really, really awesome presentation. I'm impressed.
Thank you. Hopefully, I managed to solve all the technical issues before I give the talk again. I apologise for that. It was something's not quite right with my setup here. So
No,
I'm going to
these
blame
things
my
happen.
camera, I think. Yeah,
I'll
I
blame
think
both of you.
it's got to be the camera, because once I unplugged that, it all suddenly started working without any issues. So
All right. So if anyone's got questions, feel free to open their mic. Dylan, since you're running the restream through your through Twitch and YouTube, if you have any questions, feel free to, from any of those people, feel free to ask.
thank you. Thank you.
All right. Well, then I am gonna. There's no questions.
No.
No. Okay. Well, ask in the chat if.
Well, I'm on Twitter. If anyone's got any questions after, they can always hit me up on Twitter or drop me an email. And yeah, happy to answer them. Yeah, open to ideas and suggestions how to make it better.
All right. Find him on GitHub, Twitter. Stay in touch with him if you want to, or try the project out yourself. All
Yeah,
right.
why not? It'd be great.
So thanks again for coming. Before we go into group time, just a reminder, our next meeting is going to be the second Wednesday of May, so that's May 6th. I think I got the dates right. I'm always bad with the dates. No, that is not May 6th. That is wrong. It's going to be May 13th. So ignore that date. It's May 13th, not May 6th. But 6:30, I'll send out announcements on meetup.com, and you'll see posts on Twitter with @RockXamarin when that comes. Again, Clifford, thanks for coming. This was an awesome presentation. Really appreciate you taking the time to present this.
Thank you for having me.
All right. And I have stopped the recording. And we'll go into group time. I'm going to turn off my presentation.